Our lesson today is the mole triangle. Specifically, we're going to use the mole triangle so we can do particle to gram to liters conversions. Now, you've already done moles to mass and mass to moles, particles to moles, moles to particles conversions. The mole triangle allows us to go all the way from particles to liters or particles to grams and vice versa. The mole has three equivalent values. The molar mass, 6.02 times 10 to the 23rd representative particles are in 1 mole. And a new thing that we haven't talked about yet is 22.4 liters of gas at standard temperature and pressure. Each one of those equals a mole. So we can have this thing called the mole triangle, where the mole is in the middle and each one of the things that represent the mole is on the corners of the triangle. Now, we're not going to worry about the 22.4 liters of gas yet. We'll get to that in the gas law chapter. And also remember that particles represents atoms, molecules, formula units, etc. And the molar mass is dependent on the specific compound. But the mole is represented by all three of these. And we're going to use this knowledge when we're going to do multi-step conversions involving the mole, grams, particles, or liters of gas. I am tired of talking about the mole. So are my other chemistry teacher buddies. We've decided to take a vacation from the mole and go skiing. So we're all going to meet at Pittsburgh Airport and take one flight out from Pittsburgh to our ski destination in the Rockies. Unfortunately, we're all coming from different cities in the United States, so we all have to meet at Pittsburgh first, and then we can take one flight out together. So I arrive first, and I arrive at B38. And our flight out leaves from A13. Now, I would love to be able to walk from my gate directly to my other gate in the shortest path. Unfortunately, I can't do that. I have to walk along the concourse for safety and security, and then up to my gate. Our next buddy comes in at about a half hour after I do, and he lands at D80. And again, his only pathway to the gate that we're going to all leave from is again down his concourse and then up a concourse until he gets to the gate. And finally, our third buddy arrives, and he arrives at gate C54, so right here. And again, his only pathway is to run or walk up this concourse to get to the gate. Now, why did I bring up this airport analogy when we're talking about the mole? What did you notice? You noticed that anytime we had to go from one concourse to another concourse, we always had to go through the center. We couldn't go a direct any way. The only direct person had this way, but everybody else had to go down their concourse and then up another concourse. Now, what's that got to do with the mole? Well, if you remember, the mole triangle has three corners, and then the mole sat in the middle. So we could relabel our airport here with exactly what's going to happen when we talk about the mole triangle. So let's do that real quick. So I've relabeled everything with the appropriate corners for a mole triangle now on top of the diagram for the airport. Now, what do you notice here? Anytime that we want to go from a mass unit to a particle unit as far as a conversion, we always have to go through the mole. Anytime we want to go from liters of a gas to the mass of the gas, we always have to go through the mole. Anytime we want to go from liters to particles, we go through the mole. No matter which conversion you're going to do, we always have to go through the mole. The mole is our central point for all our things. So let's see how that works on a real mole triangle. Why didn't you just show me this little diagram first instead of that silly airport diagram? Well, I wanted to show you with the airport that this is very similar to that was very similar to the mole triangle. In other words, if we start here at mass, we do have to walk down the mass concourse to get to mole first before we can go out to any of the other equal molar representative units. So mass to represent the particles, I can't go from here to here. I have to always go through the mole. Same thing with this pathway, same thing with this pathway. The other thing I wanted to show you was that when you go into the mole from any one of the corners, we're always going to divide by the appropriate conversion factor. So I'm going from particles into mole, I'm going to divide by 6.02 times 10 to the 23rd. When I go from volume of gas into the mole, I'm going to divide by 22.4 liter. When I go from molar mass to mole, I'm going to divide by the molar mass. And then when going the opposite way out, we're going to multiply by the appropriate conversion factor. In this example, we're going from moles to atoms. So we've set up our equation where we start with moles and we want to end up with atoms. So we start with moles here and we want to end up with atoms here. So again, we have to match units. So we've done that. And now when we do the math, you can see what we're doing. We take 3.5 moles. Remember, the unit conversion from moles to atoms is the Avogadro's number, 6.02 times 10 to the 23rd. We match this large number with the word atom or molecule or particle, and then we put 1 mole. So when we do the cancellation, the only thing we're left with units is atoms. And you can see here that we're multiplying when we're going out from moles to atoms, 3.5 times 6.02 times 10 to the 23rd. And we divide by 1. 1 times 1 is 1. So essentially we're multiplying two large numbers together to get even a larger number. And there's we go. So as we go out from moles, we multiply. In this example, we're going the opposite direction. We're going from atoms to moles. So here's my atoms, moles. So I've set it up atoms. So let's look at our units. Atoms here, and then what we're looking for is moles. So again, we cancel them out. And as you can see, when we do the math, we're taking 1.8 times 1 and then dividing it by 1 times 6.02. So we actually are dividing it, and we get this number here. So when we go into moles, as we're doing here, from atoms into moles, we divide. So another visual to help you understand what we mean by divide and multiply. We start at moles. When we want to find the number of particles, it's the number of moles times 6.02 times 10 to the 23rd. Particles will give me the total number of particles. Moles times the molar mass will give me the number of grams. Grams divided by the molar mass will give me the number of moles. Particles divided by 6.023 times 10 to the 23rd will give me the number of moles. So into moles, we're going to divide. Out from moles, we're going to multiply. So multi-step conversions are just single-step conversions all linked together in a continuous chain. We're going to use the same methodology that we did with setting up a single-step conversion, except now we're going to keep mindful of the units every time we add another conversion step. Remember, everything for chemistry has to go through the moles in these conversion steps. All right, so let's look at an example real quick here, where I want to know how many atoms of hydrogen are in 45 grams of NH3, right? So what I've done is this is my given, and I put that over 1. Now, my first step is we always go from grams into moles, and to do that, we need the molar mass, and I've calculated it here, right? But now we're going to make sure that we match here the grams, and we've done that. And then the next thing we have to do is we're going to calculate the number of moles, and we've done that here. So at the end of this conversion, if we stopped here and did the math, we would have the number of moles. Right, now we're going to go, now we're in the mole triangle in the center, we have to go back out of the center. So now we're going to go from moles out. So again, our mole has to match here, and it does. And then the next thing we're going to do is we're going from molecules to molecules. Now why are we doing that? Remember, the molecule is just the number of particles in one mole. Right, we're looking for the number of atoms in a molecule from each molecule. And then the last thing is, our last unit here is what we're trying to find, and that's the number of atoms, right? Okay, so we haven't put any numbers in yet. I know there's numbers here, but we haven't put any numbers in. We just have to match the numbers with the units. So 45 grams, that's given. I know my molar mass is 17 grams. I can calculate that. That equals 1 mole. I also know that 1 mole equals 6.02 times 10 to the 23rd. And I also know that 1 molecule of NH3 has 3 atoms of H. So you can see that right here. So when we set it up properly, now the units are just going to self-cancel. Right? So we can just go through now and just cancel all the units. So that's going to cancel with that. That's going to cancel with that. That's going to cancel with that. And the only unit I'm left with is atoms. So if I've done my cancellation right, I get the proper number of atoms. And the units match. So when I do all the math there, I get 4.8 times 10 to the 24th atoms of hydrogen in 45 grams of NH3. Right? Now look what we've done here. We've gone from grams to moles to molecules to atoms. Again, grams to moles, that's one conversion. Moles to molecules, that's another conversion. And atoms, molecules to atoms, that's the last conversion. Here are 2 more examples. I'm not going to spend a lot of detail setting up the equation, but I do want to let you know this. If you set up your equation right, the units on the top of the equation will give you the pathway of your conversion. Right? So I'm going to circle all the units on the top. We don't care about the units on the bottom. Right? Now let's look at my problem. How many molecules of water are present in 30-gram sample? So I'm starting out with 30 grams of the sample, and I want to know how many molecules. So my unit pathway is, follow the bouncing ball basically. I'm going from grams, I need to go into moles, and then I finally go to molecules. So I'm starting with grams, I convert to moles, then I convert back out to molecules. In this particular problem down here, what is the mass of a sample that contains 3.12 times 10 to the 24th carbon atoms? Again, before we even put any numbers in, my given unit is atoms. I'm going to moles. I'm ending up at grams. So if I read my equation here, my problem here, it says I have this many atoms and I want to know what the mass is. So the mass means grams. So I'm going to go from atoms to moles, moles to grams. So it basically tells you the pathway you're doing. Here's our last example of a fully set up problem that's been worked out with all the steps. Again, here what we're trying to do is we're going from 525 grams of carbon tetrafluoride, and we want to know how many molecules. So again, if we just go from the unit to unit dimension analysis, we start with grams, we need to convert to moles, then we end up in molecules. So our pathway is first the conversion here, then the conversion here. We don't care about the things on the bottom, right? And if we had another one, we would make that conversion here, and then you could keep doing that as many times as you needed, right? And I've given you the steps right here. Step 1 is convert from grams to moles, and step 2 is convert from moles to molecules or particles. I've calculated here the molar mass of carbon tetrafluoride, and that number is my conversion, and that goes there. You already know the conversion value for moles to molecules, and that's the Avogadro's number. Here's where you're going to practice it yourself. So you're going to stop the video, write all the information down, work the conversion mathematics and equation, get your answer, and then restart the video to check your answer. So stop the video now. The answers to the two parts of the questions are shown. 52 grams of sodium bicarbonate equals 0.619 moles. And here's my equations for setting that up. Grams start, put that over 1. 1 mole of sodium bicarbonate is 84 grams of that. That's the molar mass, and you have to calculate the molar mass. I get 0.619 moles. That's my new start point for this one. Now remember, I need this to start here to go from moles to molecules. And when I do that, that's my final answer. The last thing we're going to do is to check your understanding and knowledge of the concept that we've just tried to teach you. So here's where you're going to practice it on your own. You are going to, when I tell you to, stop the video, write all this information down, work the problem, come up with a solution, and then restart the video to check your answers. So when you are ready, stop the video now. The answer to the two problems are presented. I just wanted to show you real quickly. I didn't show you all the math, right? You should get 1.5 moles of nitrogen. Remember, now we're going from what is my sequence here as far as conversion. I'm starting out with particles and I want to go to grams. So I'm particles to moles, moles to grams. In this one I'm starting out with grams and I want to know how many particles. Grams to moles, moles to particles. The last one here I'm going to do with you together because it's a little bit more tricky. But I'm going to set it up first and then I'm going to walk you through it. So I'm going to stop the video real quick, set it up, and then walk you through how I did it. So I've set up the equation and I'm going to walk you through how I set it up. So the first thing is 16 grams of sodium chloride is how many total atoms, right? Now remember, each sodium chloride has 2 atoms in it. So when we get to the end, we're going to have to account for both atoms. So we're going to do it just like we did the other ones. We're going to set it up real quick, and we're going to say that there's 16 grams of sodium chloride, which is what I'm given. I put that over 1. Now the first thing I have to do is do my conversion into moles. So I know my grams have to match, which is they do. Grams here, and I know that 1 mole of a substance equals its molar mass, and I've calculated the molar mass as 55.8. I'm now going to move from moles into particles because I'm going from grams to moles to particles. So I've done that here. Remember, the mole here has to match the mole here, and I get particles. So at the end right here, I would have the number of particles. If I calculated all this here, I would have the number of particles of NaCl. That's just the particles of NaCl. Remember, each particle of NaCl has 2 atoms. So now I can say 2 atoms for every 1 particle of NaCl. And I've done that here. So let's just cancel all the units now so we can see that they're all getting canceled. So the grams is going to cancel. The moles are going to cancel. The particles are going to cancel, and I'm going to be left with atoms. Alright, so I finished the calculation, and I got 3.24 times 10 to the 23rd atoms in 16 grams of NaCl. And I think I did the math right. I did it in my head. So I should be pretty close. It might be 3.21, but you should be in that ballpark, right, if I did it right. So this should be your final answer for this problem here, after you've set it up and done all the math correctly. So if you have any questions, find me in class and we can discuss then.